Hi there, and thank you for clicking on this video. This lesson is going to cover some of our traits of polynomials, namely degree, leading coefficient, and more specifically, end behavior. Please like this video if you find it helpful, subscribe for more math content, and check out the practice set for this lesson and the other videos that we have on the channel. So I wanted to start off just by discussing a little bit of traits of polynomials and where this lesson and topic fall in the higher or like broader sense of what we study in algebra. Now, much of what we do now with polynomials is done on a graphing calculator. And if you go back to when I was in high school and then go back further to like when my mom was in high school, there was a lot more stuff that you had to do by hand. And as our technology has advanced, many of the things that we do by hand have really become outdated. They're very long processes, they're complicated processes to get information that we can get in a matter of moments if we know how to use graphing technology. But some of the concepts are still easier to do by hand once you know some key pieces of information. So, and this is really one of them, your degree, leading coefficient, which lead into understanding about the end behavior of polynomials. This is still going to be faster and easier for you to do than using graphing technology. So we want to be selective in what we're using our technology to do. Starting with degree. Degree is simply defined as the highest exponent in a polynomial. And if you're taking notes, so if you're doing this in place of a lesson or to supplement your notes, I would write that down. When we talk about the degree of a polynomial, we're referring to the highest exponent in that polynomial. Now, for example, lines are polynomials of degree 1 and quadratics are polynomials of degree 2. So when you're coming at a unit on, say, higher order polynomials, what is good to remember is that you've already been studying polynomials. So everything that you did when you studied lines, say in Algebra 1 or early in Algebra 2, and everything that you've studied with quadratics, again, both in Algebra 1 and Algebra 2, you were studying polynomials. And that's good because that can give us a really solid foundation. If I were to look at at a linear function, say 2x minus 3, we know that the exponent on that x there is a 1, and so this would make it a polynomial of degree 1 because the highest exponent in that function is a 1. And we could do something similar with the quadratic. So if I were to say negative 3x squared minus 2x plus 4, and we look at the highest exponent there, the highest exponent is 2, and both of those meet the definition for polynomial. So it might be good to keep that in mind. In fact, I'm going to use that in presenting this lesson. So if you remember things about lines and things about quadratics, it's really going to help with this next piece. Now, the leading coefficient, which I will often abbreviate LC because leading coefficient is quite a bit to type and write, is the coefficient of the term that determines the degree. And that will be the first or leading coefficient when the polynomial is in standard form, and that is when the terms are in order of decreasing exponents. So there's actually a jumble of vocabulary there. We've got the vocabulary, the definition for leading coefficient. Then we have this thrown in here, the vocabulary for standard form. So there's nothing about leading coefficient, the definition of it, that says it is the first coefficient you'll see. It is the coefficient of the term that determines the degree. However, when a polynomial is in standard form, the highest exponent will be on the left-hand side, and that will make the leading coefficient the first coefficient you'll see. We'll look at some examples of that. I'll throw some at you that are both in standard form and not in standard form. So here are some examples here. I guess that was a little redundant. Here are some examples here. Here are some examples. So looking at this first one, we want to kind of scan for the highest exponent. And so we see an x to the third, we see x squared, we see x to the first. And this over here is actually x to the 0. If you recall that an exponent of 0 is equal to 1, so that's 3 times 1. Okay, we don't usually write the x to the 0, but I mean, it does go 3, 2, 1, 0. Now that that is in standard form. So when we talk about the decreasing exponents, that is what we're referring to when the exponents go 3, 2, 1, 0 in that order. And that means that for this one, the degree is 3, and that makes the leading coefficient 2, because your degree and your leading coefficient will be on the same term. So the leading coefficient is the coefficient for the term that determines the degree. The degree, if it is in standard form, it is going to be the first coefficient you see. Now, the next one is also in standard form because the exponents are in decreasing order. So we see the highest exponent here is 5. Now, notice that we're jumping over the exponent of 4. That doesn't make it wrong or anything. It is something to note, though, because when we get to studying polynomial division, if you haven't already studied that, you will need to know that you have a 0x to the 4th there. Then we have the 3, the 2, the 1, and in this case, the constant is missing. But the highest exponent is a 5, and the coefficient that goes with that is the -3. So in this one, we would say the degree is 5, and the leading coefficient is -3. And lastly, this one is not in standard form. Okay, so this one, the exponents go 2, 4, 0, and 1 is the order of the exponents. And the definition of degree is the highest exponent. So that means this is degree 4, and the leading coefficient is going to be the +6. And you could also get the leading coefficient is, I think I've defined it this way for my students before, the leading coefficient is the first coefficient or the coefficient on the left when the polynomial is in standard form. So if we were to rewrite that in standard form, we'd move the x to the 4th over to the left, then we'd have x squared, then we'd have 2x and 4, and that would put your leading coefficient in that leading spot as you're reading from left to right. So we want to just keep that in mind. People will get sneaky about that. And sometimes when you're doing application problems, the way you dump your polynomial out when you're reading the description of it, it ends up not being in standard form. Now, remember that if you don't see a number, the coefficient is 1. So if you were to see something like this, just x squared plus 1, that your leading coefficient would be 1. And if you were to see a negative x squared, your leading coefficient would be -x or -1. So just keep that in mind. Every time I teach this, I will have students tell me that the coefficient is x. They don't see a number and they'll just tell me the x instead. Okay. Now, end behavior, which I will often abbreviate EB. End behavior is what the function does at the extreme left and the extreme right. Now, typically it goes up or goes down for polynomials. So if we're talking about polynomials, what we mean when we say end behavior is as I move further and further to the left and I kind of move past all the other things that might be happening, what does the polynomial do? Does it head up as it goes off the left end of my coordinate plane, or does it go down? And the same for the right-hand side. Now, there are 4 possibilities for end behavior, and I'm going to sketch them like this. So you could have something like this. Now, what I'm going to do is I'm going to put these dots in here. Okay, and those dots signify that there might be other things. It doesn't necessarily come down in that nice curve there. It could do something like that. It could do that. I don't know. It could be doing a whole lot of things. Okay. I don't really know what it's doing, and I'm not going to draw it so that it's doing something. I'm just going to draw the ends. So one of your possibilities is that both sides point up. The left hand points up and the right hand also points up. And along with that, you could have something like this, where both ends point down. Or you could have your mix and match where one end points up and the other end points down. So that could be something like this. Okay, and once again, like I have the dots in there because it could do something like that where it kind of ducks down. It could go up and then duck way down. It could do a lot of different things. We don't know. Okay, so we're gonna leave that middle part as like a dashed out, like I'm not sure what's going on in there, but in that one, the left side is pointing down and the right side is pointing up. And I should probably do this because this is often a point of confusion. There's your left, there's your right, okay? And we could have the other one where it's pointing in two different directions, but it's the other way. And again, just where you have left and right. Every year, again, there are students that get these wrong because they don't know their left and their right, and they get the words backwards. So yeah. So there's the left. Now, those are the four possibilities. So those are the only four things that a polynomial could do. And now the question that everybody has on their minds is, how does end behavior relate to the degree and the leading coefficient? So we talked about what is degree, what is leading coefficient, and then we have this thing called end behavior. How are these all connected? All right, so first case is, what if you have even degree and a positive leading coefficient? So you have a degree that is 2, 4, 6, 8, 10, 12. I mean, hopefully you're not staring at a polynomial of degree 12. If you are, go do a different math problem. And the leading coefficient is positive. So if that is the case, then you are in this situation. Okay, and I'll give an example. Might be something like f of x equals 3x to the fourth, okay, plus 2x minus 1. And in that case, you have an even degree and a positive leading coefficient. If you have that, then that's what your end behavior will look like. Next one is even degree and negative leading coefficient. Well, that is this one. And an example of that might be f of x equals negative 3x to the fourth plus 2x minus 1. So now you still have the even degree, but now the leading coefficient is negative. And if you tie this into what you know about transformations, basically it flips it over. So it's not this random thing like you've never seen this before, it doesn't connect to anything else. It is the flipping over. So positive, like they both point up like happy people. Negative, they're both pointing down. And what I will often tell my students is it's like a parabola, which makes sense because a parabola is degree 2. So parabola is an even degree polynomial because it is degree 2. And if you think, okay, a parabola, if it's positive, it's not transformed. It'll look like this. If it's negative, it will be transformed by flipping it over. And so if you can remember what polynomials do when you have a negative leading coefficient, then you can get all of the rest of the polynomials along with it. So that brings us to, what about odd degree and a positive leading coefficient? Well, that's this one. And I've always thought of like odd being not balanced. So in my head, I picture even things as being balanced. Like if you have 6 of something, you can put 3 on one side and 3 on the other. And there's this like balance to it. And so an odd number doesn't have balance. If I have 7 and I try to split them, then I have 4 on one side and 3 on the other side, and it's going to cause it to tilt funny. And then in my head, I picture this. So if you're kind of wondering, how does a math teacher picture this? That's kind of what I'm picturing. So an example of this one might be f of x equals 2x to the 5th minus 2x squared plus 4. And so we're looking at an odd degree, that's the part that makes it unbalanced, and a positive leading coefficient. And that leaves us with the last one, which is odd degree and negative leading coefficient, and that is going to be this one. And as an example, we might just take the one we had and we're going to put that negative out in front, and for some reason, I wrote that as plus negative instead of a minus, but just roll with it. And we've got the odd degree and now the negative leading coefficient. Now, what might be helpful for you here is, like with the even, we can say, oh, it's like a parabola. Well, with the odd ones, they are like lines, which I hope makes sense because a line is an odd degree polynomial. It's degree 1, which is odd. And this would be if it has a positive slope. So if you have a line and it's positive slope, this would be like if it has a negative slope. Okay. Now, what students tend to get wrong is, or mixed up, I don't want to say they get it wrong, but easily mixed up, is remembering which one matters. Okay. So you're not thinking about whether the leading coefficient is even or odd, or whether the exponent is positive or negative. In fact, if it's a polynomial, the exponent cannot be negative. Okay, the lowest it can be is 0. If you've got a negative exponent, you're dealing with some kind of rational function instead of a polynomial. So the exponent is always going to be positive, which might help you remember that, okay, that's the one that you care about, whether it's even or odd, and it's the other one that it's positive or negative, the leading coefficient, because only the leading coefficient could be negative in the first place. Okay, so these were some examples from Desmos, and I'm aware if you're watching this on a phone or like a smaller tablet, this is probably excruciatingly small. So I will do my best to verbally give you what you need out of this. But basically what I did was I went into Desmos and graphed a bunch of these so we could look at them. Now, in this first one, this is f of x equals x to the third minus 5x plus 1. And if we look closely at it, this is an odd degree with a positive leading coefficient. So it's positive post. Let me fix that. Positive leading coefficient. And take a look at this. So I can put like the little arrows on that. Okay. And this one is behaving like a line. Now there's two ways that you could state the end behavior. The informal way is to simply say something like this: the left goes down and the right goes up. Okay, and we're basically saying just the left-hand side of the polynomial is pointing down, the right-hand side is pointing up. Now, there is a more formal way of writing that, which would be probably expected in your advanced placement or college classes, maybe not in an Algebra 2 class. It really depends on the teacher and what the teacher is aiming for or what's important to your teacher. So sometimes for my classes, I'm okay with the left goes down, the right goes up. That's enough information for me to tell that my students are looking at the right thing. Now, the more formal way we would say this is as x approaches negative infinity, f of x, or you might see y, approaches negative infinity. So let's kind of break that down. As x approaches, that's what that arrow means, negative infinity. That is a fancy schmancy way of saying left. Okay, so if you look at your x-axis and you go towards negative infinity, if you trace where my pointer is, negative infinity, I am moving to the left. Okay, f of x is the same as y. That's a fancy schmancy way of saying down. So as your y approaches negative infinity, well, here's my y-axis. As I go to negative infinity on the y-axis, I am going down. So this is just a fancy way of saying left goes down. And we could say the other one, as x approaches infinity, f of x approaches infinity. And same reasoning here. As x approaches infinity, well, if you look at your x-axis, to go to infinity, you're moving to the right. And if f of x is your y-axis, to go to infinity, you are going up. So this is your more informal way of saying it. This is a more formal way of saying it. All right, so this next one is f of x equals negative 2x to the fifth plus 7x to the third minus 3x. And just notice on the graph, look at the jumble of stuff you've got going on in there. It's like wiggling up and down and going, doing all kinds of stuff, okay? And we're not interested in that. We are interested in the extreme left and the extreme right. So we might say for this one, the left goes up and the right goes down. Using our more formal notation, we have our fancy way of saying left as x approaches negative infinity, f of x or y approaches infinity. So not the same answer as over here. So this still means to the left as x approaches negative infinity, but this time as I go to the left, it's pointing upwards. So I want to say f of x approaches infinity. And then as x approaches infinity, that's my fancy way of saying to the right, f of x is approaching negative infinity, a fancy way of saying down. Okay, let's take a look at the other two situations that we might have. I have a slide out of order, so we're going to do this one. So what is useful to know? While graphing utilities can tell you end behavior, it is faster to be able to determine it using degree and end behavior. That's like the whole slide there. Like it takes more time. Well, let's like click over here. Okay. Oh, no, my other slide is, well, this is an adventure. I'm not re-recording this video, so like there's another slide though, because I can see it. Well, I'll say it now. We'll do it in the middle. Like and subscribe if this lesson is helpful, although you might want to watch till the end of the lesson. Drop a comment below to engage. You can slam me and say, hey, you need to re-record this video because a slide got dragged out of order somehow. And then check out the practice set to review what we covered here. I will link the practice set on the next slide. I'll make sure I allow some time after I stop talking to do that. Okay, so the other one. So this is the slide that got dragged out of order. Now, what I was saying about why this is useful, it actually takes more time to type that into Desmos than it does to recognize what the end behavior is on its own. So if you look at this, this is 5x minus x to the fourth plus 2x squared minus x to the third. Now this one is not in standard form. So you want to go find that highest exponent, and you can find the highest exponent is a 4. And so you're looking at that x to the fourth. So this is even degree and negative leading coefficient. Well, as soon as I hear even degree, I think, well, this is going to be like a parabola, and the negative leading coefficient means it's going to be flipped over like that, which means this is going to go down on the left and down on the right, okay, which we can see from the graph. But it's faster for me to find the degree and the leading coefficient and say, oh, this is even, this is like a parabola. If it were odd, you'd say, oh, this is like a line. And the formal way of saying this is as x approaches negative infinity, that's my to the left, f of x approaches negative infinity. So that means the left is pointing down. As x approaches infinity, my fancy way of saying to the right, f of x is still approaching negative infinity. It's still heading down. All right, last one. We've got this one, f of x equals 2x to the sixth minus 4x squared minus 3. And what I notice right there is 6 is even, which tells me it's like a parabola, okay, in terms of the end behavior. It's clearly not a parabola. You can look at the graph, not a parabola, but the end behavior is like a parabola, and the 2 is positive. So this would be like a parabola that is not flipped over. And you can see that when I come over here, you look at the end behavior, like they are both pointing off of the screen there. So we could say that it goes up on the left and up on the right. And our more formal way is as x approaches negative infinity, f of x approaches infinity. As x approaches infinity, going to the right, f of x is also approaching infinity, going up. Okay, and so there we go. Now, I have told students that I would actually rather have them answer like this because this is a lot harder to grade. You just have to, as a teacher, you got to pay more attention to it. But you always answer however your teacher is telling you to answer. Okay, that's what you do. All right, so that's it for this lesson. I don't have my typical slide at the end because we already looked at the typical slide on the end. So I'm going to put this up here so when I process it, I'll know I'm done talking, and you should at this point see some kind of link appearing at the bottom for you to check out the practice set, and I encourage you to do so you can practice what we covered in this video. Thank you for bearing with me and my out of order slides, and I hope to see you in a future video.